Hello, this is Nicholas Nikolic. I am going to run quickly through, take about 4 minutes of your time to chat about the experience at Argonne. Um, it was a lot of fun. It was a lot of fun. I ended up working pretty hard to understand their issues as well as how they pertain to us. Um, and this is the report. Um, Basically, there was a few main tenants. Probably the biggest tenant, a full third of the week, if not half of the week, was on IO. It was about computing, and in the work that you do, both on Mortimer as well as for Argonne, is going to need um, thought and design in how to approach basic input output. All the machines are unique. All the machines there are frankly designed for different takes on input output. Processing and parallelization aside, there was a good deal of content, as I mentioned, on how to get your files through the processors. There was a good deal of emphasis on SYCL and OpenMP. Some work on CUDA, but I wanted to give you my takeaway, and that was that we should not wall ourselves in particular CUDA. It's good for our Mortimer system, in particular, was it Saha GPU with the A100s. However, if you're going to be building for Argonne, just be aware that more open approaches are going to be probably extremely fruitful. Any parallelization system is going to have the pitfalls of I/O, meaning that it's pretty apparent up to 75% a hit in performance if your data is not packed into the machine in ways that are palatable for that machine. So with that caveat of my main takeaways, the vocabulary to remember are OpenMP, SYCL, SYCL, and I'd like to point out probably my strongest feeling in regard to work at Argonne or work at Mortimer. I'd like to work with the team to get used to the idea of using containerization technologies, so that particularly what's in use at Argonne is Singularity, which is a Docker-based container. It is it's a good idea. Each scientist would get their own volume. Each scientist would get their own processor to spin up, and some of the hardware is exposed through it, and the work gets done that way. All right, so I'm going to go ahead and play through my video and chat as it's playing, and I'll just go ahead and comment on things. So we start off with the who's who of Argonne depicted. You might want to zoom into that particular. Each slide is 10 seconds. This is the Nexus services. These are available services at Argonne. This is the This is the family of argonne machines. Um, Here we have the tools that offer different capabilities of workflow. It's about 50 slides. We'll get through them quick. This is a workflow tool called Balsam, probably the oldest workflow tool, but best supported. Um, let's see, moving on to the next slide. There's my finger. These are the workflow tools, including Parcel, Globus, which I wanted to talk to you all about. Globus is here's another slide of Globus. Globus is a workflow tool that we might want to consider at UWM, but it's um, a project of U of Chicago, and it allows some upload as well as monitoring features for your jobs. This is DAOs. This is the Aurora file system approach. Well worth about a month of study if you're going to spend time in it. This is Polaris. This is the machine that we'd be spending most time on. This one is additional information as to how to interact with Polaris. These are the common problems that come up with that they see. This is the FAQ. Here are the storage systems. Again, Deos is one of them, most performant, but others are there too. This was an incredibly fruitful talk on what are the systems, different qualities. This is the head, or close to the head, of data science at Argonne. Well worth remembering that name. Here are their throughput over the years and over the machines. This is more on their particular qualities of processing. Tips for I/O and data management. It's worth pausing there. That guy was really smart, and furthermore, again, about a third of the time we spent on I/O. Insight. This is the information as to how to apply for an insight allocation. These are all the systems at Argonne out of the ALCF program. And this is the Argonne guest house sign. Hard to find, especially at night when I got there. And that's the front entrance of Argonne's guest house. Again, hard to find, especially at night. It's worth asking for directions. Okay, so that's all my slides. I just wanted to reiterate again, our work most of the entire week was learning different tactics of AI. Different tactics of I/O, and then ask questions to me in Slack if you have any other queries. I'll happily answer as best I can. But again, just want to reiterate, Singularity, the Docker-based container technology, I would love with all my heart to get at Mortimer, and it would give us some parity with Polaris at Argonne. As in, if you do the work and it's successful on Mortimer, you can speed up your processing with go with the small sample at Mortimer, and then dock that container at Argonne and find your processing done in a 10th to 5th of the time. All right, so thank you, and have a great rest of your weekend.